Welcome fellow learners. Microsoft has recently released multimodal model Phi-3 Vision, which is state-of-the-art open source model. As it is multimodal, it can handle vision data along with text data. This model belongs to Microsoft's Phi-3 family and comes with 128K context length. So if you see their page in Hugging Face, along with latency and compute benefits, this model can be used in three different use cases. The first one is general image understanding, second one is OCR, and the third one is chart and table understanding. So in this video, we are going to implement this model in free Colab space such that everyone can implement it. So we will be taking a use case of OCR and will implement this model. So let's get started. So to implement this Phi-3 Vision model, let's first switch to Colab notebook. Let's first write down what are the different steps that we are going to follow in this notebook to implement this Phi-3 Vision model. In the first step, we are going to install all the libraries required for this Phi-3 Vision model. In the second step, we are going to import this Phi-3 Vision model from Hugging Face using Transformer library. In the third step, we are going to import the processor required for this model. We will again use the Hugging Face and Transformer library. In the fourth step, we are going to create a prompt which will be required to pass to this model at the inference time. And also we will import the input image that we are going to pass to this model for the inference purpose. In the fifth and final step, we are going to do the inference. We will take this model and convert this prompt and input image to input token such that it can be passed to the model at inference time. And then we will analyze the result, how it is responding to this input image and the prompt that we have given to this model. The use case that we are going to basically see in this particular notebook is we are going to fetch the OCR result from an invoice, and we will see the result, how does this Phi-3 Vision model perform in the case of OCR when we are trying to do OCR for an invoice image. So let's implement the first step of installing all the libraries required for this Phi-3 Vision model. And also before basically installing these libraries, we need to connect this notebook to a GPU server. As you can see, I have already selected this T4 GPU, but if you haven't selected, you can go to this runtime and select this change runtime type. And here you can select this T4 GPU and then click on save. Once you have done that, you can click on this and you will be connected to a T4 GPU server. So let's uncomment this line, and you can see different libraries that we need to install. You can see all the libraries that are required to install for this Phi-3 Vision model from this Hugging Face page of this Phi-3 Vision model. If you scroll down, you can see these are all the libraries required to install. So let's run this cell. If you see, the different libraries that I have used here is NumPy, Pillow, Request, Torch Vision, Transformers. I have also specified the exact version which are written over this page of this Phi-3 Vision model. The only thing that you will see that I haven't used is flash attention. The problem with the flash attention is it doesn't work with all kind of GPUs. So it doesn't work with this T4 GPU server. So that's why I haven't installed this flash attention part. The main purpose of using flash attention in this model is basically to enhance the basically inference and training speed both. As you might know about, as these attention or transformer based models are basically having a bottleneck of self attention. So the self attention basically have quadratic time and space complexity both. So that's why it creates bottleneck when we are trying to basically expedite the inference and this training speed. But at that part, this flash attention really helps to basically increase the training and inference speed. But in our case, we cannot use this flash attention as it is not basically, it doesn't work with the T4 GPU server. So that's okay. We are going to implement this Phi-3 Vision model without this flash attention. So now those libraries are installed. So it is asking to restart this session. So let's restart this session. Once we are done with installing the required libraries, it was mentioned in this particular Phi-3 Vision Hugging Face page. So we are done with that. So we also need to install this accelerate. So this accelerate basically helps with PyTorch to basically reduce the boilerplate code. So once we are done with installing this accelerate, we again need to restart our server. So you can restart your server from here. You can click on this restart session and it will restart this particular session. So once it has been restarted, we can comment it, and then we can move on to the next part of the code. So in the next part, I am going to create a folder over here where I will be basically saving my Phi-3 Vision model. So I will create this folder, and then you can click on this basically Explorer, and you can see this folder has been created, this my models, and under it there is a folder named Phi-3 Vision. At start, this folder will be empty, and we are going to save our model in this folder. So now we are done with installing all the required libraries, and we have also basically created this folder. Next, we are going to import our Phi-3 Vision model. So to import this Phi-3 Vision model, we are going to use this auto model for causal LM. So there are basically two kind of language modeling. One is this causal LM, and second one is masked language modeling. So if we talk about causal LM, it is basically used when we are dealing with auto-regressive kind of models like GPT-2, GPT, or GPT 3.5. Those are basically auto-regressive model where the model can only see the tokens on its left side. It won't be able to see the tokens on its right side or in the future tokens. And the masked language modeling is where it can see the tokens, the model at one step can see the tokens in both sides, and basically it masks few of the tokens to predict those tokens. So as this Phi-3 Vision model is basically a causal language modeling type of model, so we are going to use this auto model for causal LM, and we will be using this model ID. You can check your model ID from here, which particular model ID you are going to use. So you can copy from here and then directly paste it over here. So this will be our model ID. And then we can use the from pretend function from this auto model for causal LM, and we can pass the different arguments which are required for this model. So now we are having our model ID. We are having the folder where we need to save this model. So we can basically put it in cache dir where we need to save this model. And as we are using GPU, we can pass this CUDA to device map. This trust remote code we need to pass such that it can trust the code from the Hugging Face and basically get and fetch all the required code for this model. And also, like this torch data type is auto, it will automatically determine the data type of the the weights and other different values of this model. So let's run this cell and let's see what it basically gives us in the next step. So the thing is, yeah, so you can see there is an error over here. So if you can see, it is saying that this model file requires the following packages that were not found in your environment: flash attention. So run pip install flash attention. But as we are not able to use flash attention with this T4 kind of GPUs. So if you go to the page of this Phi-3 Vision model in this Hugging Face, in the bottom of this page, basically they have also provided a way where you need not to use flash attention, and you can still implement this model. So what we need to do first, we need to basically comment these 4 lines in this modeling Phi-3 .py file, and then we need to pass this attention implementation as eager. So when we are going to pass this attention implementation as eager, it will basically make this model for like custom attention type, so or basically manual attention type. So let's do that. So as we have stored our model in this folder, so now we can see model is there. It is not complete model as it has encountered the error, but that Phi-3 file will be there. So we can change and basically comment out the required lines that was given in that particular page. So if we expand this, we can see these lines, this flash attention lines we need to comment. We can comment these lines and then save it. Once we are done saving, we need to basically restart our server, and we can restart our this session directly from here. We can click on restart session, and once we are done with the restart, we can again run this particular cell where we basically are fetching this Phi-3 vision model. So as we have seen in that page, we need to also pass this argument attention implementation as an eager to basically where we need not to use the flash attention part. So now we have done both the task to where we need not to use flash attention. So let's run this cell and let's see how does it work. Will it work, or will it again give us the error? So now you can see this is basically installing or basically downloading the model. So once it is being done downloading, it will basically import that model to our this Jupyter notebook. So you can see the first part of this model. There are basically two safe tensors that are being over here. So you can see that how much size of this model is from this files section of this page also. So you can see there are two safe tensors part. So one is around 4.94 GB and another one is 3.35 GB. So this model will basically download both of these part of this model and then basically import this model in this notebook. One another thing that you can see from here is like you can go to this and use the view resource part, where you can basically see what is the different RAM disk size available for your model now. So you can see the system RAM, it has used around 1.6 GB and total is around 12.7 GB. GPU RAM it has used is around 5 GB and disk size it has used around 37.8 GB. Similarly, you can monitor how much basically this model is utilizing your RAM and GPU part. So now you can see it has basically imported this model in our Jupyter notebook. So the next part is we are going to use this processor. We are basically going to import this processor. Using this processor, we are going to convert this input, that prompt, and basically the image and the text that we are going to pass to this model in a format which can be basically acceptable for this particular Phi-3 vision model. So let's run this cell. We are also using this auto processor from transformer only. So once we are imported this processor, we are good to go, and we can basically import our prompt and then convert that prompt into input token. So now you can see we have also imported this processor for our Phi-3 vision model. So we can also print the docstring for this processor, and we can see what are the different things it involves. So you can see it constructs a Phi-3V processor which wraps a Phi-3V image processor and a Llama tokenizer into a single processor. So like for text and image part both. So for the text part it will be using Llama tokenizer, and for the image part it will be using Phi-3V image processor. Now we are done with the import part. So let's create our prompt. So if you go to this page of this Phi-3 vision model, they have specified which kind of prompt we need to use over here. So if you see, it needs to pass the image as a first part in the basically prompt, and then second we can basically write down what are the instruction we need to pass to it, and in the final step we are going to basically pass the assistant, and after this assistant will be basically giving us the answer. So if you see, I have written over here as like what are the role and the basically input instruction which I am going to pass to this basically you can say Phi-3 vision model. So I have given this as role user, and the first part is same as like image, and the second is like I have passed this to the instruction which was what I want this model to basically achieve. So if you see, I have written like provide OCR for all the text in the given image and in markdown format, so that we can basically easily understand and the output should be in a better printed way. So let's run this cell. And another thing, like while converting this basically simple text into a prompt, I am using basically apply chat template function from this processor only. two things I have passed over here is like one is tokenize equals to false. We are not tokenizing this model right now. We will do it later. And second one is add generation prompt. So this what this add generation prompt will do, as we have seen in this Phi-3 vision page of this Hugging Face. Like this, we need to pass a final assistant, basically you can say word or token over here, such that it can make sure that now the assistant work has been started, and after this assistant will write down what are the output we need to see. So when we are adding this, now we will run this, and you can see in your prompt, basically this will be added. So if you can see, this assistant is added at last. So we are not using tokenize at this step. We will basically tokenize this after we have also imported the input image to us. So to import this input image, we are going to use this PIL, and basically I'm using a web image. So I will use this request function. So let's run this cell and basically see which particular invoice image we are using. So this is the image that we are going to use for this particular use case. So it has basically different things like bill to, ship to, invoice number, invoice date, PO, and all those values also, like total and subtotal. So this is the kind of invoice image that we are going to use. So now let's convert this basically the input, both image and the prompt that we have passed, prompt into a input tokens using that llama processor, and this image using that Phi-3V processor. So let's run this cell, and then we can see how does it converted this our prompt and image to basically input tokens. So you can see this is the image part, and at start you can see this is the tensor or the input tokens for this prompt. It is also used attention mask over here. So now we are having our input IDs and input tokens, which we can pass to our model. So next we are also going to use few arguments which we are going to pass to our model. So the first one is like we are going to use this max new tokens. So it will basically we can pass different numbers of it. I have used only 500. You can increase it to 1000 or something, so that that number of tokens can be generated. I am using temperature equals to 0, such that there will be no randomness, and I'm also using do sample equals to false. So let's run this cell, and we are also done with using the arguments which we are going to pass to the language model. So now the final step is we are going to inference using this model. So you can see I have passed all those things that we have used in the previous step, like arguments, the input, and also the processor. This one is like what is our end of sentence token. So there is already an end of sentence token in the tokenizer of this processor. So we are directly going to pass it to this particular generate function. So let's run this cell. Now we can see how does it perform, and also like how much time this particular model will take at this T4 for this T4 GPU to generate these 500 tokens using this particular image and the prompt which we have passed to it. So it will run this Phi-3 vision model, and it will fetch us the output, which we can compare in the next step, like which we can basically analyze in the next step and see how does this give us the result. So let it run. Let's talk about the next step that we are doing over here. So if you see in the next step, I'm basically removing the input IDs. So input IDs will be that prompt token that I have passed to it, and also the image Phi-3 which has been converted from Phi-3V processor. So if you can see, this has ran it in only 43 seconds using this only simple small T4 GPU. So and then we can do this. We can basically remove the input tokens and then use this processor to basically decode it so that we can understand the output. So it will be decoded into a text format. So now you can see the result. So you can see it has clearly marked down this, and it is really in a good basically way, so that we can directly see and compare the result from the image. So like it has basically converted it into a table. All these few things which were basically in between of this image, like front and rear brake cables, labor 3 hours, new set of pedal arm, and the subtotal. So let's compare a few of them. So let's compare this front and rear brakes. It is 100 over here, and total is around $154.06. So let's see what is the output. So we can see the total is same of $154.06, and this front and rear brake cables is also 100 and 100. And you can see it has fetched all other details also, like invoice, bill to, ship to, invoice number, invoice date, PO, due date, and all those values which were basically written in the image. It has also written this payment is due within 15 days. It is written at the bottom of that invoice image. So great, we have come up a way to implement this Phi-3 vision model without using flash attention, and it still gives us pretty good results. So basically, we have also implemented this Phi-3 vision model in free Google Colab space such that everyone can implement this without any compute resource problem. So we came up a long way in this video. We have basically first installed all the required libraries as per given in the Phi-3 Vision page of this Hugging Face. Then we have basically imported our model. Then we also imported the processor that was required for this Phi-3 Vision model. And then we created our prompt and then imported the input image that we were going to pass to this Phi-3 Vision model. And then in the final step, we converted those input image and the prompt in a suitable format to this model, which I can say like to input token IDs, and then that image to basically converted through Phi-3V processor. And then we use those to finally do the inference. And we found out it really works well for the OCR output. And we have seen that this Phi-3 vision model can be used for OCR purpose also. So great. Thanks for making till the end of this video. Goodbye until the next time.